All right, so now marine ecosystems. This is going to be where salt is. There's a lot of salt. That's the major difference between freshwater and saltwater is the salt. So if you're going to write that out for your notes, the main abiotic difference is salt. There's different things, different examples. There's oceans. You can write down. You can write seas or gulfs or bays. If you think, you should be able to think of examples from each of those. What's the type of ocean? You could think Pacific Ocean, Atlantic. You could, for seas, you got the Sea of Galilee. You got the Baltic Sea, got the Red Sea. Different gulfs. We got the Gulf of Mexico or the Persian Gulf. Different bays. You have, I think you guys have studied the Bay of Bengal or Chesapeake Bay. So all of these are going to be marine ecosystems that are going to have a very high amount of salt, especially when you compare it to freshwater, like rivers and streams, like we talked about. Marine ecosystems, just know that that is the major thing between the two is the salt. There is a difference in temperature. There can be. There can be a difference in the depth or the pressure for each. There can be a difference in the acidity of the water, but the major difference between the two is going to be salt. All right. If you look here, you guys have probably seen a tide change. This is the same picture. I'm sorry, this is the same place. It's a picture of the same place. And you can see way out, you can see ocean, maybe like something over here on the horizon. But now you see there's very little water there at all. And the reason that's there is because of the tide change. And these boats probably have something under them that makes sure that they don't get damaged when the tide leaves. If you look, it looks to be about maybe 15 or 20 foot difference between this tide and this tide, high tide, I'm guessing, and low tide. That's a big deal. And I don't know this, but this dock is pretty high up. I'm wondering if the tide sometimes even comes if it's even higher sometimes. I'm not sure. That's a huge difference. Think about the abiotic. That's a major abiotic factor change. A large amount of water and then no water. If there's organisms that are in here swimming and they can't live without water, they need to get out as the water's leaving. And the water may be leaving. Do you think that, and they could probably swim, in a foot or two of water, but eventually that water's going to be leaving. They can't swim in an inch or two of water, probably. So they need to make sure they're out of this area back into the deeper ocean before the tide completely goes out. If you look at this, this is called a tidal river. A tidal river. I don't know that this is the same location, but this does show you what it looks like. It does look very similar to this. So in this area, the water goes out in sheets. It's all kind of flat, kind of like the water at the beach comes up in flat waves. A tidal river comes in differently. When the water, if you think about this little river spot is deeper, has a little trench. So when the tide starts rising, this river, this little channel fills up first. And then as it's filling up, it's moving inland. It's snaking up like the river's moving towards those trees. And then eventually the river that little tidal area gets full, and then it starts going up into the grasses and creeping up into the grasses and sometimes covering the grasses. So you see that this looks like a tidal river going left and right, and little tidal, I guess you could call them tributaries maybe, little tidal streams, other tidal rivers that go out. That's a tidal river, and that creates an environment that's beneficial to a lot of organisms. A lot of organisms will burrow in the ground under the dirt. The water will come in where there's large fish and stuff that would eat them. When those large fish leave, now they can go around and eat. A lot of babies, a lot of marine ecosystem animals will actually lay their young or have their young here, and the parents dip out. And the babies are left to fend for themselves, but they're left to fend for themselves in this area, which is a lot more gracious, a lot more suitable, a lot more that's more protected than just the open ocean, where a whale can come and eat 1,000 babies at one time. Now it would they individually have to get picked off here, and maybe they hide among the grasses, or they hide in these little pools when the tide is out. But this is a tidal river. And I want you to focus your attention up here. These are barnacles. On the bottom left are barnacles. They would grow on the sides of this dock, anything. boats, whales, turtles, and they filter water. So when it's dry, they have to close up so they can stay moist. And then when the water comes back up, I'm guessing the water level is not much higher than the tops of those barnacles, I'll guess. This, I don't know if you can tell, but these are vertebrae. These things, this is a normal sized crab, maybe a large crab. These are vertebrae, the little bones that make up your back. This is a whale's vertebrae. So when the whale died, it sunk to the bottom, and there's a whole miniature ecosystem that is living off the things here and living off the things that are living here. So you have bacteria, you have crabs, you have maybe starfish, stuff like that are, I don't know if starfish go that deep, or sea stars. But you have a whole miniature ecosystem that's temporarily created. Organisms can come and eat. I'm guessing they can reproduce. They can do all that while the whale is being eaten for weeks and weeks and weeks. And eventually it runs out and you're left with just bones. And then the other organisms have to go find another dead whale or dead shark or dead fish that floated to the bottom. And if you've seen, you can look up time lapse of this happening. It's really cool. You see a bunch of organisms coming in slowly, and then they're all there, and then they slowly leave. Kind of like ants to some kind of treat that you drop on the ground, which is all pretty cool. All right, so here we have some animals. You see a bunch of these animals on the left. Let's go ahead and address this fish. This fish, I can't remember what it's called, but it looks kind of, you feel kind of sympathetic for it because it looks kind of funny, like those really weird goldfish you can get from PetSmart. And then it opens its mouth and it freaks you out a little bit. Like that's the same animal. It's the same fish. I can't remember what it's called. You can probably look it up. But go ahead and write down some examples of plants and animals in the ocean. You can talk about kelp or seaweed or algae for plants. Should be typing plants and animals that are in this area. You have hagfish, starfish, anemones, jellyfish, whale sharks, shrimps. You got manatees, dolphins, turtles, manta rays, all these different organisms. And I'm sure you can find a bunch of organisms as well online.